All right, guys, today we're looking at integration by substitution, also known as U-sub. U-sub is the idea of substituting in something, we usually use the variable u, to create a basic power integration. We don't want to have other things with the variable, we just want variable to the power so we can use our power rules. Or if it's a trig function, we just want trig function of variable, so sine of u, cosine of u. Now to do this, we have to think about the way a integral is written. If we look at this one right here, okay, we want to find the derivative of these two. Well, when we find the derivative, we're taking, in these contexts, the chain rule. We're doing the derivative of the outside, so 2 times 5 to the 2x squared minus 3, 4, times the derivative of the inside, 4x. Now, if we wanted to integrate, we would work perfectly backwards. We'd bring the 5 back up, so add 1 to the exponent, divide by 5. But the only way this integral works is if this goes away. And that's where u substitution comes in. So the idea is we want to find something we can make u so that its derivative is on the outside of the function. So in this case, our u will be x squared minus 3, and our du is going to be, well, the derivative of this is 2x and then dx. So if we look, we have our u here, so it's going to be integral of u cubed, and then our du is right here, 2x dx is our du. So this becomes, oops, there we go. So this becomes du. Okay? So this part becomes du. This part inside, that's the power 3, becomes u. And now we can do our basic power rule. So we'll add 1 to the exponent, u to the 4th, over 4, plus c. And then we'll plug back in our u, because we started with x, we want to end with x. We have x squared minus 3 to the 4th, over 4, plus c. And if we were to take the derivative of this, we'd do the chain rule, and we'd end up with that derivative of the inside, the 2x, back on the outside there. Okay? Another example is one like this. We have sine x cubed times cosine x. Well, we want something we can make u where we can have its du on the outside. So I'm going to make u sine of x. That means the derivative of sine is cosine of x dx. Okay? So we have the integral of u cubed du. And that's going to be u to the 4th over 4 plus c, which is sine to the 4th of x over 4 plus c. Okay? All right, we get a little more complicated when the du can't actually be found. Usually when we're picking a u, we want the u inside something we can integrate. So for example, we know the integral of sine, so we want the u to be the inside here. U is going to be 3x. Well, our du, the derivative of u, is 3 dx. But there's not a 3 here. As long as you just need to multiply by a constant, you can multiply by any constant to get your dx. So we're going to multiply that inside times 3 dx. All right, so now we have our u here and our du here. But that should start ringing some alarm bells because you can't just go multiplying something into a function and not be balanced. To balance this, if we multiply by a 3 on the inside, we're going to multiply by a 1/3 on the outside. So this is going to be 1/3 integral sine u du. Integral of sine is negative cosine, so we have negative cosine u over 3 plus c. And u is 3x, so negative cosine 3x over 3 plus c. Okay? Similar thing happens with cosine 4x. You'd make your u 4x and your du 4 dx. We can also see more complex versions of this when we have these. I'm actually going to look at this one right here. Remember, we want our u to be something that's inside a function we can integrate. Well, here we have x squared minus 2x minus 3 to the 3rd That's something we can integrate. So x squared minus 2x minus 3. That means du would be 2x minus 2 dx. Well, we have x minus 1 dx. So we need to multiply the inside by 2, so times 2. And to balance that, we're going to multiply the outside by 1/2. Integral of 1 over u cubed du. 1 over u cubed is the same as u to the negative 3. And so we have 1/2 u to the negative 2 divided by negative 2 plus c. So 1 over 4 x squared minus 2x minus 3 to the second plus c. All right? And then we'll look at one more. Neither of those are really that big. Let's look at this one right here. Okay? We can integrate something in here. We want to look for something that we can integrate. Well, we can integrate the something to the power of 3. So let's make our u tangent x. Our du, derivative of tangent, would be secant squared x dx. So we end up with the integral of tangent x cubed, which is u cubed. Secant squared x dx is du. This just becomes a simple power rule. So we have u to the 4th over 4 plus c, which is tangent to the 4th of x over 4 plus c. All right, so this is the only video I'm going to make on u substitution. The other two are just building on this concept, so it should be easy to ask questions and get your understanding for. So if you have questions about any of the future u sub lessons, please come ask. This is the basis that we're starting with and building off of. Y'all have a great day.